Hello everybody, get ready to do lesson 3.5 of Algebra 2 Math, part 2 today. You want part 3, email me here to get that, as well as worksheets and quizzes and online tutoring. You can get that as well by emailing me there. Today, part 2 of 3.5, graphing square root and cube root functions. We have a 26-point classwork sheet today. Get your classwork sheets from me by that email. And no note-taking today. Here is our objective. So page 1 in your classwork sheet today. Solving a multi-step problem here concerning pendulums. The period of a pendulum is the time the pendulum takes to complete one back and forth swing. The period t in seconds can be multiplied by t equals 1.1 radical L, where L is the pendulum's length. So we can find the time it takes for that. Using a graphing calculator to graph the model. So we're going to graph the model, enter the equation y equals 1.11 radical x. Graph is shown here. Here is that graph for that function. The period t in seconds can be multiplied by t equals 1.11 radical L, where L is the pendulum's length. So here is the curve for that. So the period of a pendulum is the time the pendulum takes time, blah, blah, blah. Where is the length? How long is the pendulum with a period of 3 seconds? So we can use the trace feature now to find the value of x when y equals 3. The graph shows us when x equals 3, when y equals 3, x equals 7.31, which would be right about here. So when y equals 3, x equals 7.31. A pendulum of a period of 3 seconds is about 7.3 feet long. That is where that function gives us that solution. So using the model in example 3, find the length of the pendulum with a period of 1 second. Down here, students, find the period of a pendulum with a length of 2 feet. Find the length of a pendulum with a period of 2 seconds. So there's your independent practice there. Page 5 on your. Let's get into our guided practice here. So the period can be multiplied by this. So here is our curve again for that. A pendulum with a period of 1 second. So when y equals 0.99, so our period here is on our y-axis, and then the length of our pendulum is on the x-axis. So with a period of 1 second, we have a 0.81 foot long pendulum is what this amounts to here. That is 1 second, which is our y value here. So, and that was it on the calculator. Translations of radical functions. The procedure for graphing functions of the form like this and like this, cube roots here of x minus h plus k is described below. So the graph of a radical function, to graph y equals a times x minus h radical plus k, or this here, you have to follow these steps. Sketch the graph of y equals a to the x, a radical x, or y equals a times the cube root of x. Translate the graph horizontally, h units, so this is our horizontal translation here, and vertically k units, so this is our vertical here, would be our k units. Vertical translation there. So graphing a translated square root function, here is the graph of y equals -2. -2 times radical x minus 3 plus 2. Here is the graph of y equals -2 times x here. And then here's the translation here. So sketch the graph of y equals -2x, shown in blue. Notice that it begins at the origin and passes through the point 1, -2. So it begins here at 0, 0, and then when x equals 1, y equals negative 2. That's an important point there. And then translate the graph for y, for this graph here where h equals 3 and k equals 2. So the shift of the graph of y equals negative 2x is right 3 units. So we go right 3 units here, 1, 2, 3. And then up 2 units, and then 1, 2. So instead of being the origin here, this would be the virtual origin for this function here would be at 3, 2. And passes through the point 4, 0 here. So when x equals 4, y would equal 0. And then you could get that from getting a table of this too, going into table in your calculator and finding that. From the graph you can see that the domain of the function is x is greater than or equal to 2, 3. This is where the graph starts here. And the range of the function is y is less than or equal to 2. So this is where the max here of your range is. It starts here and it goes like that. Okay, graph function and state the domain and range. We got this here to do, class. This is here. This is yours down here to graph. Let's get into our guided practice now. Here's our function here. So to graph this and state the domain of range, we have a situation here. It goes like this. And then the domain and range of this is because h equals 0 and k equals 2 in this situation, shift the graph of y equals negative 4 radical x up 2 units. So instead of starting here at the origin, it goes up 2 units. So this is where it starts here. And that is lesson 3.5 part 2. Part 3 is available here, as well as classwork worksheets, tests, quizzes, and homework. And online tutoring. Email me here for that as well. Thank you very much.